Good morning, everyone. Thank you for being here for this talk and for the invitation. We are researchers from the Athena Research Center, and we'll give you a talk about how we, during the past year, we work on an open Greek LLM that we call it Meltemi. I'm Vassilis Katsouros, Sokratis Sofianopoulos, and Giorgos Paraskevopoulos. So I will give you some introduction, then I will talk about the data that we used, some details about the training procedure, evaluation, and the next steps that we are working on. For us, you know that the world of AI changed after the OpenAI issued the ChatGPT, and for us it was a great challenge to work on an open LLM that has a Greek flavor. Training from scratch, or what is the difficulties that we had to face. So we have many challenges in front of us, like data, computational power, and different algorithms. What was the most cost-effective, because the resources are not unlimited. So it was continual pre-training or of an existing foundation model and not doing the training from scratch. And you know, during the past year, there were many open LLMs, like Llama 2 initially. At the end, we decided to adopt the Mistral, the 7 billion, and the size is also matters in this case, because depending on the size, you have to calculate also the computational resources, and that will be also easier to be used not only for research, but also for innovation. So our motivation was to have open LLM, to see how we can work and get our hands dirty with cutting-edge technologies. Our aim was to support the Greek language, so and all the different parts that the open LLMs had already for the Greek language. For us, openness means transparency that allows other researchers to verify, inspect, and improve even the model, and would like to have a community around these open source models, and even take them and fine-tune in their own datasets. And of course, support the education, but also the entrepreneurship and innovation by open that for commercial purposes. So we had 3 challenges that we faced. The first was to, you know, LLMs need a huge amount of data, large amount of data. And for us, it was where we can find them. The quality of the data, it's another very important issue. And also the copyright. Can you use the data, or can you share the text? And these is very important parameters as you are collecting data for doing your work. And we didn't release the data set. We can release, we have released a few data sets, but not all of them, because it was very difficult for us to see if there was a copyright breach in this data set. So we preferred not to share this text, but only use them. The second challenge was forming a team. You know, all these works need a versatile skill set, and that involves, you know, NLP, AI algorithms and frameworks. The Greek linguists, data engineering, and of course, a lot of software development. And another important aspect is collaboration, how you make those people collaborate with each other, because they are coming from different cultures, and it takes us some time to synchronize the team. And last but not least, another challenge was the computer resources. The cost, so that's an important aspect. How the availability. We didn't have the time, or unlimited time, to access, you know, these computational resources. So we had to make a planning and do our small-scale experiments, and then deploy everything in cloud computing, a high-performance cloud computer. And of course, another aspect, very important aspect, is how scalable these solutions can grow, especially with, because it's not only the training, it's also the deployment and the inference. And that's an important aspect as well. Facing all these challenges, we went along, and as a team, we had to select at some time a name. And for us, since we based our work on Mistral, and you know Mistral is the north-west wind in south of France. A very important, a nice, you know, paradigm in Greece is Meltemi. It's a north wind in summer breeze, and that was our thought behind choosing the name. So, training data sets. Sokratis.
Hello. So, the first thing we need to do is collect the data that we are going to be using for the training. LLMs, as you all know, require huge amounts of data. And Mistral 7B has seen a vast amount of data, even though not a lot of Greek. So we needed to collect as much open license Greek texts as we could in order for us to apply continual pre-training on the existing model. The fact is that we do not need that much data as we would if we would start training from scratch. So that was a big help from our selection to continue pre-training the model. So we started collecting as much high-quality Greek text as possible, and we also needed to add some English text as well, so to tackle catastrophic forgetting. We did not want our model to not be able to speak any English at all. Because as a matter of fact, Greek is lowly represented all over the world, so a lot of times, a lot of people would ask questions a large language model and would expect some kind of English answer as well as Greek. Okay, for example, technical terms and so on. We also enriched our data with some parallel English to Greek translation. We did that because we wanted to learn the relationship between the two languages and to be able to seamlessly switch between Greek and English as the model answers the questions that the users give it. Also, we wanted to add translation capabilities to our model in the future. So this is what our data comprise of. So we have 40 billion tokens that we used for training, Out of these 40 billion tokens, 28.5 are Greek, 10.5 are English, and then we have a small amount of parallel data. The pipeline that we followed for processing the data in order for us to use for training was first of all to start by collecting our data, either from publicly available datasets or from web scraping. We then collected all this raw data, which we then passed through a natural language processing set of tools in order for us to filter the data, to clean them, to deduplicate them, and then to complete our process by having a training-ready dataset for our model. The Greek data sources that we used had to be high quality, so we did not want any blogs and so on. Of course, not only for the fact that they are not high quality, also for the fact that they have no free license. Okay, so we selected sources like Wikipedia, ELRC-SHARE, which is a repository for the European Union. We used parliamentary proceedings, we used the EURLEX corpus, we used Makoku, Kultura-X, which are huge corpora that contain multilingual data and contain a lot of Greek data as well. This is the part of the data set that Vassilis talked about, that we do not actually know the licenses of these data sets, so we do not release our produced training data set, but we have the sources right here. And also we use various academic repositories, theses, abstracts, and so on. The data preprocessing pipeline that we followed was, first of all, we started by extracting text from PDFs and HTML documents. We then converted them in a metadata-enriched JSON format. So for each data source, for each data set, we not only had the raw data, we had also the source that the data came from. And then we continued by applying a preprocessing and filtering set of steps. First of all, we applied rule-based filtering, some heuristics, example, minimum word length, text that we are definitely sure that they are not real text. We also used some scores and some thresholds, such as, for example, fluency scores. We used 7-gram KNLM models that we trained on existing clean Greek data. And also, we used alignment scores for our parallel data that we used. If any of you has used laser from Meta, you all know what I'm talking about. Also, we applied document-level deduplication using 5-gram in-hash algorithms. And finally, we ensured that data distribution remains balanced throughout training. So whenever we feed a batch of data to our model for training, we made sure that the approximate percentage of data is specifically as we want it. A lot of Greek data, some English data, and then a few English to Greek parallel data. George?
Okay, so I will talk you a bit about the training procedure we followed. So the training procedure we implemented consisted of 3 steps. The first step was to extend the vocabulary of the Mistral tokenizer, because as we said, Mistral hasn't seen a lot of Greek texts. So we saw that this affected the vocabulary also. Then we had to warm start the new embeddings. Because we extended the tokenizer, we created some new embeddings which were randomly initialized. So we needed to give them a heads up to what's coming with the fine-tuning, and then we did the continual pre-training where we tuned the whole model. The whole training took 25 days. It consumed about 2,300 kilowatt hours. That's like going 10 times to Thessaloniki. And then in this estimate, we include the failed experiments, which we estimate took about a week or so, a bit more. And the good run took about 2 weeks. So, the original Mistral tokenizer had some problems. It has in some Greek, but it did character-level tokenization because that's how the algorithm works. It didn't see enough data to compress the Greek effectively to subwords. So we needed to extend it for Greek subwords. We used to extend the context length and to capture more context and more semantics. So what we did is we separated the corpus of about 10 million words, and we stratified this split across the subcorpora Sokratis talked about, and then we trained a subword model on this corpus. Then we added the new tokens to the tokenizer, and we avoided double entries from possible previous tokens. And the result was that the original vocabulary size was about 32K words, subwords, and then we extended the vocabulary to about 61K subwords. And as we said, these new about 30K subwords were randomly initialized in the embeddings matrix. We figured that this would slow down training or even destabilize it a bit. So we needed a better initialization strategy for these new embeddings, the embeddings matrix. And we followed this procedure where we first initialized them with to be the average of the other embeddings, the trained embeddings. And then we ran a fine-tuning step on a small subcorpus of our training corpora with all the parameters frozen except these. So this gives us good initialization values. And then we applied continual pre-training. One question is, why not start from scratch? Continual pre-training is the method from the domain adaptation literature. And the key idea is very simple. I have a model, I want to fit it on new data. Let's train the model a bit on the new data, and then it will have a good performance. And there are three questions that concern us here. First, does it work across languages? Second, is it faster than starting from scratch? And the third, is it better than starting from scratch? And the literature says yes to all of these questions. It's cheaper, it produces better models, and it works across languages. So that's what everybody follows when they want to extend a large language model to a new language. So, as we said, we selected Mistral. The most common question when we present this work is, why not Llama? And the answer is very simple. Mistral had good performance at that time, and it had a permissive license which allowed for both commercial and research use. So, a few details. Mistral is a 7 billion parameter model. It has it has 32 layers. It has 8K context length, and it achieves this through a series of computational optimizations, like sliding window attention and some good caching strategies for to avoid the attention recomputation. And very little is known about the training data. What is assumed, it has in English, it has in French, it has in Portuguese, mainly a few European languages. And now it has in Greek too. And the frameworks we use for training are Hugging Face, PyTorch for the model and data processing, and we used DeepSpeed for the multi-GPU training. We trained about 25K steps, and the batch size was about 4.5 million tokens. And here are some training curves. We include the failed experiments here. As you see, we ran a few runs. We started some runs, we stopped them, we restarted them, and yeah, this is what they look like. And one thing we figured and we found out is that research, especially when it comes to large language models, becomes more about logistics than about ideas. And this is a very pragmatic take, because with large language models, data, the training with huge amounts of data is very expensive. And you can't follow the bottom-up approach of trying different things and sticking with what works. So we had to make sure a lot of things were good when we started training. We had to make sure that the code was fully debugged, fully tested. We had to make sure that we had a good overview of the literature to try some ideas without experimenting, just borrow from what others did. And we had to have a good intuition about this, because I said about the warm start of the embeddings. We didn't see this in the literature or in our experiments. We just thought this would work based on our intuition. So a lot of top-down modulation is needed here. So the outcome is Meltemi, the foundation model. It is good across a variety of tasks like translation or text generation, with varying degrees of success. And we find that evaluation is crucial, both in Greek and in English, to see how this compares to other solutions. So Sokratis will speak about the evaluation a bit. Mm-hmm.
So next we wanted to evaluate our model so as to know how well can it perform in various tasks. Even though it is a foundation model, it can perform, as George said, a variety of tasks. So for evaluation, we used a combination of quantitative and qualitative assessments so that we can check how does the model perform across various tasks. The methods that we used are very common in LLMs. We used some benchmarking tools on standard data sets. We used some quantitative metrics like perplexity, accuracy, blend, root scores for translation, word error rates, and so on. And also we did some human evaluation as well as error analysis on the results of the queries that we did to the model. So to that end, we created a standard evaluation suite for Greek that is integrated with the LightEval framework. We also evaluated on the OpenLLM leaderboard tasks for the English datasets on these benchmark tools. So the LSP LLM evaluation suite for Greek comprises of post-edited, translated versions of publicly available and established English benchmarks, mainly from two categories, for language understanding and reasoning, as well as general question answering. So what we did, we selected part of these huge data sets, and we translated them using high-quality transformer-based translation models between English and Greek, and also we've post-edited them so as to increase the quality as high as possible. It also contains a novel benchmark that we created with questions that have been extracted from past medical exams, which we named Medical MCQA for Greek. All of these data sets are publicly available from Hugging Face. So, if you go down here, κάτσε να το στείλω.
Δεν χρειάζεται να ακούσουμε μετά.
If you click it here, it opens here.
Αν βγούμε από το full screen. Και να το στείλουμε, ωραία. Ναι. So you can see here in our Hugging Face page, you can find all the models, not only for Meltemi that we have released, as well as the datasets that I talked about. So if anyone wants to evaluate an existing LLM or a language model that they trained on their own, they can use these datasets to evaluate them on these tasks for Greek. So each one of these datasets, I'm sure that you have seen how do they look like. You can find some examples. It is not, for example, for MMLU, we don't have the whole data set. We have just selected a subsection of the sentences that they have used. So these are the breakdown of our evaluation suite. That's the number of examples from each metric that we used. And these are the results. This is how does the model evaluate for Greek. We compared it with the original Mistral 7B so as to know how well has the model improved its Greek understanding compared to the original model. So our evaluation showed that Meltemi performed consistently higher than Mistral, and overall, on average, it enhances the performance by 20 points. Our evaluation uses various few-shot settings because of the fact we wanted to be consistent with the OpenLLM leaderboard. So we did not want to make our own evaluation tests. We wanted to use existing tests used throughout the community. We also wanted to evaluate our model for English. So we used the original datasets for evaluation, also with specific few-shot settings. Now, our model performs worse than Mistral for English, trailing by 6 points. But of course, the difference was expected. Okay, so the difference in style between Greek and English, the fact that it uses a completely different alphabet, are all things that we need to take into consideration when comparing our model with Mistral for English tasks. In order for us to make sure that our model performed worse as expected to English, but it is on par with other efforts throughout the community, we compared our results with similar efforts. So out there are a lot of people that want to apply continual pre-training to Mistral or other models, as a matter of fact, for their own languages. So we found two such efforts. One is LeoLM, which is a German foundation model created by applying continual pre-training on Llama 2. And also they have reported that their German benchmarks improved on average by 4.8 points, and their English benchmarks achieved lower averages by 2.6 points. Also, there is a Japanese foundation model created by applying continual pre-training on the same model that we used, Mistral 7B, and they also report an improvement in Japanese benchmarks by 8 points, and also a lower average scores by 5 points on the English benchmarks as well. So we consider our results as similar to others in the research community.
Now let's go to the second stage of creating a useful model. And I say useful model because the task that the foundation model performs is not very useful. It's just sentence completion. So if we stayed there, there would be far fewer people here, and NLP would be a lot less interesting. What we want is a chat model that can answer users' questions. And this is done by instruction tuning. What is instruction tuning? We have two broad variants. One is supervised fine-tuning, where we present the model with pairs of queries and responses. And we train this in a supervised way. And the other variant is human preference learning. There are a lot of algorithms for that. We are now experimenting with ORPO, which requires triplets of query, bad response, and good response. And we created about 100K instruction pairs for training, for supervised fine-tuning. And these pairs are obtained from OpenPlatypus, the EvolInstruct dataset with machine translation, and from Capybara. And for OpenPlatypus, we selected only subsets with permissive licenses. Here is an example of an instruction in OpenPlatypus. The instruction reads, find all possible permutations of the word tartar, of the letters in the word tartar, and the response reads something like, if you want me to permute these letters, I will use a known formula from mathematics for permutations, and in this particular case, the n permutations are 6, and so on. And one more step is to include some safety instructions to avoid harmful content from the model. Some internal versions of Meltemi are very good provide very good instructions on how to create bombs, how to do a lot of things. And therefore, we translated some English safety instructions first. And then we created a set for Greek safety, specifically. We did not include examples here. You don't want to see them. And after the steps, the evaluation looks something like this. For the evaluation datasets, the chat model is overall better. For some test sets, it's a bit worse. For some test sets, it's a lot better. But on average, it's about 3 points improvement. And then we go to the final step, which is the inference. How do you use this model? The full model is a bit too expensive to run consistently, so quantization is needed. The key idea in quantization is to compress the model weights and to use a smaller bit width for each weight. This reduces the model size from 15 gigabytes to 5 gigabytes, and surprisingly, it has a very small performance reduction. And we deployed the model using Ollama. Recently, we used a very useful tool. If you need to use one tool for deployment, then it should be this. It's LiteLLM, which is like a reverse proxy for LLMs. Basically, it pretends to be the OpenAI API, so everything that can use OpenAI can use Meltemi. So if you've written some code that relies on OpenAI, you can use Meltemi as well, without changing your code base. So, Sokratis, do you want to list the outcomes?
Yeah. So the outcomes from this work is the release of all the models with Apache 2.0 license on Hugging Face. So we have two model variants currently. We have the foundation model, and we also have the chat model, and we finally have quantized versions to run locally. We have AWQ versions, we have GGUF versions. Depending on the tool that anybody uses, you can use Meltemi either way. We also shared our evaluation suite with all the data sets that we created so as to use it. Finally, we have the model open to use at meltemi.ilsp.gr so that you can use some of the versions that we have created of the chat model. We have a few ORPO versions. We also have the original Instruct versions. Some of them are more safety inclined, so they're easier for you to get an answer. I'm a large language model and I cannot provide you with the answer that you want. Others are more free to answer questions of that kind. Some of the models that we have are more, let's say, imaginary, so they can give out more interesting answers. Others are more strict, so you can choose and compare the models from this interface. So the next steps for our team is, first of all, to try to gather more data resources so as to have more high-quality data to train our next models. We are currently working on a mixture of experts models, such as Mistral H7B, so as to get a bigger model and have higher quality results. We are also thinking of applying a similar technique to Llama 3. We are currently working on training the tokenizer of Llama 3, which has some issues. I think we have finally figured it out, so we needed to create a new code on Rust in order for us to train a tokenizer for Greek using tick token and the Llama 3 tokenizer. And finally, we want to expand our model's capabilities by creating fine-tuned models for translation, for instruction following and chats, for creating synthetic Greek tasks from existing data, and also to apply our model for various retrieval augmented applications and function calling agents. We wanted to thank GRNet and the OCRE framework for our collaboration, because the fact is that if we did not have these resources, we would not be able to train our model. So these resources were provided by GRNet. I think that's it. Thank you very much.
much for the presentation. Are there questions? Please.
Hello, I'm Giorgos Vassilis, and that's a great work. I have a question about the different language models that you also showed, and I've seen that there is a higher improvement over the Japanese one. These may be random, or I wonder whether it's the fact that maybe Japanese is a language that it's very different. I guess the alphabet of Japanese could be very different from European ones that are closer to English. And I'm wondering whether it's this improvement then corresponds to the impact of the continual pre-training that you applied to the Japanese language. And I'm wondering whether, in the end, the evaluation metrics that we have for different languages make sense, because different languages have very different structure, but the objectives that we are training models are always the same, like predicting not always the next, but probably some masked parts of the same sentence. While we know, for example, for specific languages that we may expect to have anti-diametrical words, like in German. In German, for example, we expect to have some words in the end that we expect from the beginning. And I'm wondering whether this idea that we have for the structure of the language can help on injecting this knowledge even from the beginning.
Just to give you an idea, the evaluation, if you notice, is based on translation, actually, the data sets. So you have the noise, the parameter of the noise that comes from the translation, the automated translation. And that's also for the German, the Leo LLM, also the Japanese, and also for ours. So the better the quality of the evaluation data, we don't know, I mean, we use the following, the same technique, and we made the comparison. It could be, small fluctuations, like 1%. It could be coming from any other reason, but from the original data. And we don't know also I think the number of resources that they use for Japanese is more or less the same. I think they had around 30 billion tokens. So in terms of size of the data sets, also the German more or less is the same. The number of parameters, of course the German, they had the Llama 2, I think. For us it was Mistral. But the number of parameters also plays some role in the actual performance. I don't know if...
One correction, we didn't create the Japanese and the German models. Yeah. We just checked the performance gap there as a sanity check. So as you saw in the German model, there was a much smaller performance improvement because most common models have already seen German. It's not that large of a gap to close. For the Japanese model, you saw a moderate improvement. I assume there it's because of the Japanese language, how it works. The tokens are already there. It's a big vocabulary, but the tokens are there. In Greek, we had to extend the vocabulary because it just did character level, which loses a lot of semantics and a lot of context. That's why you saw such a big gap. Now about the benchmarks making sense, this is a very open question in the NLP literature, if you can actually evaluate these models. The answer is you do the best you can. You have some benchmarks, new are created all the time, the old ones are overfitted all the time, so it's a constant battle.
Just a very quick follow-up, and probably a silly idea, but would it make sense in order to accelerate training to say that, okay, let's have an instruction tuning task where I give to my model a grammar book, and I want the model to basically follow instructions based on the grammar book. So in a sense, I initiate the model. I have a warm start, but not with embeddings of tokens, but rather a warm start of rules. And would that make sense, or would that accelerate at any point, like the training?
Yeah.
That's interesting, but that's not how neural networks really learn. Neural networks learn by showcasing examples. If you want to do the neurosymbolic stuff, it's another area of research.
Something very close to what you're asking is that we are trying to create synthetic data. So one of these bullets that we want is we want to be able to create synthetic Greek tasks from existing data. So we want to be able to create synthetic instructions based on, for example, grammatical examples, so as to feed to our next instruction model, something like that.
Other questions up there first?
Hello. I would like to ask, in the section of data filtering, you mentioned mean word length. For example, in Greek we have articles oito. What do we mean word length?
In context, we wanted to remove sentences that are too long and sentences that are too short.
Sentences, no. Okay.
Yeah.
Thank you.
There was another question, I believe, there first.
Hi, thank you for Meltemi. I wanted to ask regarding Llama 3, your current work. Since it already knows some Greek, have you tested whether it's necessary to do continuous fine-tuning on it, pre-training, sorry, instead of fine-tuning? Do you actually need to train on the embedding layers, or could you fine-tune and use way fewer resources?
Well, the Llama 3 has seen a few Greek, but if you test its tokenizer, it has not seen that much Greek, so it is not that much better than Mistral's tokenizer. So this means this makes sense for us to retrain a tokenizer so as to be able not to break down text in characters, but rather than in subword units. So this is some of the initial experiments that we did. Is we worked around the tokenizer of Llama 3, and we saw that it is not as good as we would expect it to be.
Okay, interesting.
And also, a second point here, if you try Llama 3, the hallucinations are extreme. And one thing you need to consider is not about just language proficiency. It's not about just the model speaking Greek, but also knowing about the Greek everyday life, the Greek culture.
Yeah.
If you ask the model, how do I do my taxes? It doesn't say you go to IRS, like all the other models. It's a lot more than just generating
That's
good
true.
Greek.
So you need to do continuous training.
And another thing about tokenization, you know, the tokenizer, changing the tokenizer, you improve the efficiency in the inference, during inference, because it's much cheaper inference.
Right.
Whereas with the original tokenizer, it's more expensive when it is token-based.
I see.
The
A second quick question. Have you looked into HIAS, the Cohere model? It knows some Greek as well.
Yeah, we have used it. It's really good.
Right. Okay, but you're more interested in Llama 3, in training Llama 3 for now, I suppose.
Is Cohere? I don't think it has
The license.
such permissive license as Llama 3.
Yeah, it's very restricted. Okay,
There is
fair
also
enough.
Gemma that
Right.
came
Yeah, it's
a few
very,
days
very
ago,
recent.
and
Yeah.
it seems to have a permissive license, but we were looking at this.
It does. Okay. One last question. Oh, okay.
Ask for one question, let others ask questions, then
Fair
use the
enough, yeah.
microphone again.
You can ask afterwards.
Okay, yeah, sure.
Thank you very much for the presentation and the whole effort. I think it's really, really important that we think about like localizing these models. To me, like seeing all the evolution of transformers, I think are like not that many things. Like every paper will claim that they do some sort of magic, but like not many things have substantially changed in the architecture that I would be surprised that they would reason much about the performance. So to me, the whole magic that nobody really talks about is the data. And even behind the big companies, like the data is what is the most important thing. And what I find part of the magic there is the data processing pipelines, like when you have to deal with PDFs and you make them text, you have random page numbers floating, random headers, like, or where you scrape web pages, how do you remove usernames from forums, or like all these things. I'd love to hear your some more insights. I'm sure that many more in the audience would love to hear some more insights of how you try to reproduce or create more of that magic.
Yeah, it is an important part in the pipeline. Now I cannot get into too much detail. I'm actually not personally working on such a thing. But it is very important to be able to extract, for example, information from tables, from PDF documents, and so on. Or text processing is the most crucial part in such models because, as you said, everything else is similar to everything else everybody does. So for us, the quality of our data is the most important thing. And this is what we think about when figuring out how to move forward. We need to find more high-quality data. So I'm not sure if the solution would be to create synthetic data or just to be able to find openly available data that we can use. And also things have been changing around the pipelines as well. For example, there are a lot of work done on decontamination now in data sets. So as people are sure that all of these benchmarks are not inside the training data that people have been using.
So it
And
was,
also,
it was trial and error, and we were checking the quality in the pipeline, and at the end we were checking the quality and we were throwing away, texts that were not of good quality or they were very noisy. We kept them on the side because it needs some other, post-processing maybe to improve the quality. But depending on the time that we had, we wanted, to gather as much data as possible. So, kind of good quality.
yeah, as Vassilis says, it's more inductive work. You just, it takes a lot of inspection, you extrapolate some rules, and you apply it to the whole data set. So, but that's as per how what is more important, because what I see is the data collection is more collaborative than just us doing applying these rules to clean some very dirty data. So as I see it, creating good LLMs is good for the whole economy and a good strategic step to take as a country in general. So there are more high-level stuff to be done, like talking to the big newspapers and asking them to provide some of their data, or talking to organizations they have good data and requesting them to provide them. That's a bit more what Vassilis does, not what we do, but yeah, it's much more collaborative than just inspecting and throwing out some headers in the HTML.
We are trying to form an alliance for the Greek language that bring together all the stakeholders that own copyrighted and very good quality data, and we would like to find a framework of giving them incentive to not to share openly the data, but to share for training an open LLM, and that will be good for all of us.
There was a question up there before, I believe up there.
Thank you for your presentation. Based on your experience, do you think there is a way to detect if a given Greek text was an output from your model? So another way to ask this question, do you know of any ways to add a watermark on your output of your model?
No.
No. This is a very difficult task that we have not worked on, and we have definitely not used any watermarking techniques on our output.
Okay, thank you.
Do you have any date cutoff for the Greek data you train on? So, for example, do you train on Katharevousa, 19th century Greek, Hellenistic Greek, ancient Greek? What sort of Greek do you use?
After 90s. Yeah. I mean, we didn't. That's a very important aspect because if we want to see the Greek language and if we want to go to the ancient Greek literature, we have to bring into the training data set all the different periods of Greek language. That's a very good challenge. Ancient Greek, or putting polytonic Greek, it's one of the tasks that we will like to see, first, to see what will be the outcome, just putting a few sources of ancient Greek.
Yeah, just another question. Text, speech to text is very stable in Greek, right? So wouldn't be possible to use speech to text systems to create enormous amount of data, still all the Greek spoken every day?
I have made the logistics. You need 25,000 hours of spoken data to create 1 billion tokens, words.
Is this a lot?
It's not a lot.
It's not a lot.
I mean,
people speaking,
But it's for 10 channels, 2 years, I think, or two years of or 10 years from 2 channels.
And then
Spoken language, 24 per day, 36, 300.
You get a lot of context, what the context that you don't have into the other LLMs are not trained to the Greek matters.
Another thing of the pipeline was the duplication. Especially if you were collecting data from the web, you have different, especially in media, you have replication of the information. So you need to remove this duplication, the multiplication of the data. And also to increase the quality, like adding 2 times or 3 times Wikipedia. Multiplying good quality of data and trying to remove as much as possible from the noisy data.
As an economist, I was always interested in building a chatbot answering financial questions, like asking the share price of the particular share, particular company, and also use some other indicators like beta or N per share. And because you mentioned expanding the particular model, because in yesterday's lecture I learned that there is some GPTs developed in finance, and when I returned home, I tried I found something on the internet, but when I asked for share price of the Athens stock exchange, they didn't have the data to answer me the question about the particular share price. So, do you think it might be how possible it could be to enrich the particular model so it could be expand to more function, like answer financial data or something? I think it might be useful for investors.
The last 2 bullets.
Yeah.
The last 2 bullets.
And also, these data are generally very protected. So, if you know somebody who can provide this data for us, we can do it.
But it's a very nice application for combining structural data and non-structural data in applications like finance.
Okay, there's a question up there.
Is there any comparison? Wait for the microphone, please, because I don't hear you on the other side.
Hi, thanks for the talk. Is there any comparison between the cost of using OpenAI system versus Mistral, as far as the cost of a token? If you as a commercial user, you're charged XYZ amounts per tokens for the answers that come out of these LLMs. Has this analysis
Can you speak up?
Can you speak up because we
Yeah,
can't hear you.
is there a comparison of the cost between using a ChatGPT in Greek as far as the cost of the tokens is concerned versus using Mistral, or are you not at that stage yet of commercial application?
Version of using Mistral or Meltemi? Well,
I can answer that. So basically, the GPT, the OpenAI, has very competitive pricing. Google has more competitive pricing even, because they utilize batching. What they do is they batch together the queries of pretty much everybody, and they create an economy of scale. We don't have that for Meltemi. Therefore, I think it's still cheaper because it's a much smaller model, but you won't see very much difference in pricing, the difference in pricing you might want to see. It's not proportional to model size. It's proportional to the user base.
Okay, there's another question. You asked a lot, so I will bypass you, and you can ask afterwards, I think. Andrea.
Thank you for your presentation. This is not a technical question. I was wondering if, well, you know that most of this audience is other graduate students from various Greek universities. Do you have any special suggestion or recommendation for these people how to approach and exploit your products?
There is an organization, it's called UniAI. I came across 2 weeks ago, and we are talking to them, and it's an association of undergraduate students, very, very active in the area, and we are working on them. Actually, tomorrow we're having a call with them to organize something to get you know, the community of Greek students and university students to provide the API, have hands-on workshops, and try themselves, you know, for any purpose.
Another question, if I may also, since you mentioned about prices. When we hear about these LLMs and people say, oh, it's only Google, Microsoft, and others, and OpenAI who can do these things because they have the money. So perhaps an indiscreet question, how much has it cost to do this? Is it possible? What did it take? If I may ask, if I understand. Maybe.
We will be talking about only the computational power, right?
Forget the people.
Forget the people, etc.
I mean, we don't forget the people, but...
Actually, it was we didn't have any funding for doing that. It was a challenge for us. And that's why I said, you know, it was a challenge to form a team that we had on the side. That was a side project. But it was a challenge for all of us. And the computational resources were very important. So we had a GPU server of 10 A600 GPUs that we, for the small scale experiments. We made a differentiation of the 2 months that we used this actual GPU cluster, and it was more or less in electricity. It was approximately 1,500 per month, so it was 3,000.
So that's about 3 orders of magnitude cheaper than what I hear about
and then you have to add on this the credits that we took from Amazon. It was around $50,000. So the whole work was around, you know, less than 60,000
And if I may say,
It was continuous pre-training.
Yeah.
And 7 billion.
I mean, since the time of Thermopylae, we are famous for these numbers of being better. But what is better? Why can you do it with much less money than they claim to do it?
We don't claim that you can do it with less money. It's the selection of continuous pre-training and the 7 billion model.
Okay.
And if you notice here, I see many people try to, register on this, and all the models here, they are the the 5 point, so it's quantized. So we don't have the resources to deploy the actual 25 gigabyte model. So because you need to allocate, and even for the Greek Amazon team, it was very difficult for them. It took us a month to allocate us an appropriate, Ohio or GPU server for doing the work. And I think for the Greek community, we start learning, how to use these resources and how to implement things on scale and this kind of, large data sets.
Congratulations, and thank you very much again.
Thank you very much.